So, onwards to slightly more difficult topics. We're now looking at centripetal acceleration. Centripetal acceleration is just the name of the acceleration of an object undergoing circular motion. So, the acceleration is equal to r omega squared or v squared over r, and the two are interchangeable. And because force is mass times acceleration, we have F equals mv squared over r, or F is equal to m omega squared r. Okay, so those are the formulas that you need for this section. So, nice easy question to start off. A particle moving on a horizontal circular path of radius 16 centimeters with a constant angular speed of 5 radians per second. The acceleration of the particle is r omega squared. So here's r, here's omega squared, we get 4. Okay? So it's an acceleration, so the units are meters per second squared, and it's important that we use SI units and convert this 16 centimeters into meters. So this is a slightly harder question. It's about a car that's travelling at 50 kilometers an hour around a bend that can be modelled as a quarter of a circle with radius 90 meters. So, 50 kilometers an hour is equal to 50,000 meters divided by 3,600, which gives you 13.8 meters per second. So, as the circumference is 2 pi times by 90, gives us 565.2 meters. Let's just get the meters in there. Then the period is 565.2 divided by 13.8, which is 40.96. So as omega is 2 pi over t, we have 2 pi divided by 40.96 gives us 0.153 for our value for omega. So the acceleration is equal to omega squared r, so that's 90 is the radius, times by omega squared, so the acceleration is 2.11 meter per second. So this question, a little bit harder, not really, a little bit harder. Find the tension in the string. Well, the string is what's causing the particle to move in a circle. Okay, it's what's causing the circular motion. So it's what we call the centripetal force. And so all you have to do is plug the numbers into the equation, making sure that everything's in SI units, and you pop out with the correct answer. This topic is looking easy so far. I know what you're thinking. I hope it gets a little bit harder. It will. Okay, so I like this question a lot. It's about two particles separated by a string, or attached by a piece of string, and the string goes through a hole in the middle of a table. So we've got this is going around in a circle, and the centripetal force is caused by the tension between the two. Now obviously the tension in this is equal to mg here. So we've got mass times by gravity, that gives us that's equal to that centripetal force. And so find the linear speed at which p must move if q is in equilibrium, 10 centimeters below the table, gives us that the length of this string, if this is 10 centimeters below, this is 20 centimeters because the overall length of the string is 30. And so we plug that into the equation, and that gives us, so this comes up, this comes down, square root it, done. Okay, so that was easy. Don't worry, it'll get harder. Okay, but it's still not too bad. That's centripetal forces. I hope you enjoyed. If you didn't understand, try looking again, and hopefully that'll help.